Sample 31. An overflowing dam serves as a broad-crested weir such that its crest, 12 meters long, is 3.6 meters above the upstream bed. The depth of water over the crest is 0.9 meter. Calculate the discharge over the dam by calculating the coefficient of discharge first. Calculate the discharge using the direct formula. Calculate the discharge over a submerged sharp-crested rectangular weir with length of crest 1.5 meters if the head upstream is 1.2, this is H1, and the head downstream is 0.6, this is H sub 2. The crest is 1.8 meters P above the bed of channel. So for the discharge over the dam, which is considered broad-crested weir, it is broad-crested rectangular weir. It is Q equals 2.953 CL head to the 3 hubs, where C for broad-crested weir is 0.65 over square root of quantity 1 plus H over P. So C is 0.65 over square root of 1 plus, the head is 0.9 and P is 3.6 because the crest is 3.6 above the upstream bed, so that's P. So C is 0.5814. Substitute into the formula. Q is 2.953, 0.5814 times 12 meters times head 0.9 to the 3 hubs. So the discharge is 17.59 cubic meters per second. Then for the second part, the discharge using the direct formula. The direct formula for broad-crested weir, when the depth corresponds to critical depth, is Q equals 1.705 L head to the 3 hubs. So substitute 1.705 times 12 times 0.9 to the 3 hubs. So Q is 17.47 cubic meters per second. Then for the third question, the discharge over a submerged sharp-crested rectangular weir, the formula for submerged discharge for submerged weir is Q sub S equals Q times the quantity 1 minus quantity H2 over H1 raised to 1.5 and the entire quantity raised to 0.385. So Q sub S equals Q 1 minus H2 over H1 raised to 1.5, then the entire quantity raised to 0.385, where Q is 2.953 C L H1 to the 3 hubs. Then let's solve for C. C is for sharp-crested weir 0.605 plus 0.611 rather plus 0.075 of H over P, where H is H1 and P is 1.8. H1 is 1.2. So 0.611 plus 0.075 of H over P, 0.611 plus 0.075 of 1.2 over 1.8. So C is 0.661. Substitute here, where H1 is 1.2. So 2.953 times 0.661 times 1.5 length of crest times head 1.2 to the 3 hubs. So Q is 3.849 cubic meters per second. Then substitute here, where Q is 3.849, H2 is 0.6, H1 is 1.2. So Q submerged is 3.849, quantity 1 minus 0.6 over 1.2 raised to 1.5, and quantity raised to 0.85. So the submerged discharge is 3.254 cubic meter per second. So that's it for this problem.